Okay, in working this problem, this is slightly different from the one you had in your practice test. The idea is the same. If you start off by figuring out where the split is, the split's right there, and we'll notice that we have a single top this time, but we have two different bottoms. We have two different bottoms. And this region has top minus bottom right there. And this region has top minus bottom right there. So our rough integral, we're going to call that from that x number, A, to that x number, that's where the change occurs, to that x number, C. So we have the integral from A to B of top minus bottom in the first section, plus the integral from B to C, I should use lowercase, of the top minus the bottom. And that cleans up to be the integral from A to B of (3x) plus the integral from B to C of negative 2x plus 12. And of course we find A by setting the top and bottom one equal to each other. We find B by setting bottom one and bottom two equal to each other. And we find C by setting bottom one and top equal to each other. And solving those equations, A is 0. Solving this equation, so B is 12/5, and this equation, so C is 6. So let's take this top thing right here, plug in our numbers. We have the integral from A to B of 3x plus the integral from B to C of negative 2x plus 12. And so the antiderivative is 3x to the 2 over 2 from 0 to 12/5 plus the integral of negative x squared plus 12x from 12/5 to 6. And in the interest of time, I didn't bother making you plug that in your calculator. We'll just leave it like that. All right, problem 2, we have the boat. We have the boat traveling at a constant velocity for 12 seconds. That's when he cuts his engine, 12 seconds. Now, I'm going to write this as velocity equals some constant times t to the n power. And these two are my constants, that is 10 times 12 squared, which is 1440. And there's my variable, so my n power is going to be negative 2. And so my velocity is 1440 t to the negative 2 for t greater than 12. So now for t less than 12, the velocity is 10, constant velocity. And the distance is simply 10t. For t greater than 12, my velocity is 1440 t to the negative 2. And my distance is how far I traveled at the constant velocity plus the integral after I cut my engine. So it is 120 plus the integral from 12 to sometime k of 1440 to the negative 2, which is 1440 to the negative 1 over negative 1 from 12 to k. So my distance is 120 plus negative 1440 over t from 12 to k. Do a little cleaning up on that. That is 120 minus 1440 over k minus negative 1440 over 12. And 12 goes in 144 10 times, so it goes into 1440. I'm sorry, 12 times goes into 1440 120 times. So my distance is 240 minus 1440 over k for time greater than 12. All right, so now we're down to the next part, which says 8 seconds and 8 is less than 12, so the distance I've traveled is just 10 times 8, 80. 24 seconds is greater than 12, so the distance I've traveled is 240 minus 1440 over 24. And this part winds up being 60, so the distance is 180. And when it comes to rest, and I have it divided by k, well, your limit as k approaches infinity of divided by k is 0. And so the distance it's traveled is 240. 240. All right, next page. This is your substitution rule, which you need before you can do integration by parts and partial fractions and all that trig stuff. So we're going to start. And remember the pattern we use in our video, which I ask you to use for this, is to identify which derivative that is and find the parent antiderivative. And then use some algebra to figure out what your constant A is, and then plug all that stuff in to find your solution. So looking at this, I'm going to guess that is A times e to the u. So my antiderivative is du. A times e to the u, lose your du, plus a constant. Remember why that is, because when you take a derivative, you multiply times the du, and constants become 0. So taking the antiderivative, you have to divide it out as long as it's compatible. All right, well, if that's the case, then u, if that's e to the u, then u is 3x squared minus 5, which means du would be 6x dx. You have 8x dx out of that 6x dx you're supposed to have, so a is 4/3. 4/3 e to the u plus a constant. Now, only one of you messed up on this, and I'm kind of surprised because we had this on several of our examples. This is not an x squared on the bottom, so don't think about that being a u squared. That's just a plain x. I'm going to think of that as possibly a times u to the negative 1/2 du. Why negative? It's in the denominator, which means my antiderivative would be a times u to the positive 1/2 divided by 1/2, which is times 2/1. Lose your du plus a constant. If that's true, then u is 5 minus 3/4 x, which means du is negative 3/4 dx. And what you have is 2 dx out of that negative 3/4 dx that you're supposed to have, which is 2/1 times negative 4/3. Your a is negative 8/3. So 2/1 times negative 8/3 u to the 1/2 plus a constant. We'll clean that up a little bit. Plus a constant. All right, for our Riemann sums, we have this set of rectangles going from -2 to 9. We're going to add up all those rectangles. And each rectangle is my starting point plus some number of steps. Now, how big are those steps? Well, if I'm going from -2 to 9, my distance is 11. And we'll divide it into n steps. So it's going to be -2 plus 11 over n times the number of steps to get to that x sub I. That's what x is going to be. And of course, dx is simply 11 over n. That's how many steps we're going. So we're going to sum from 1 to n, limit as n approaches infinity, of this, the square root of x plus 2 plus 3x squared dx. And we write that in terms of calculus as my integral from -2 to 9, whose height is this, and whose width is that. All right, good luck. I hope that helped. Congratulations. Most of you did well. And I'll be here in the fall if you want to take Cal 3. Thanks.